So right over here, we have the graph of f, and then we have 4 different expressions. And what I encourage you to do is pause this video and see if you can figure out which of these expressions would give the largest quantity, the second largest quantity, the second smallest quantity, and the smallest quantity. So I'm assuming you have paused the video and you've given an attempt. Now let's work through this together. So this first expression right over here, we're taking the sum from I equals 0 to 9. So we're actually taking the sum of 10 things because we're taking the 0th thing, first, second, third, all the way up to 9. So this is actually going to be the sum of 10 things because we're starting at 0. And we start at f of negative 5 plus 0. And so we're going to take, so it's going to be, we're staying negative 5, f of negative 5 plus 0. So that's this height right over here. That's that height right over there. So we're going to take that, and then when I equals 1, it's going to be negative 5 plus 1, which is negative 4. So it's that height right over there. And then negative 5 plus 2 when I equals 2. So it's going to be that height right over there. So we're essentially going to sum up all the way. So this is going to be negative 5, all the way up to, so negative 5 all the way, negative 5 plus 9 is going to get us all the way to 4. So it's going to be all the way over there. All the way over there. And so you might be guessing, well, how do I relate this? You know, they've already kind of made us think that we're going to somehow relate this to area somehow. But how do we actually make that relationship? Because right now, as this is written, it's just giving us essentially a bunch of the values of the functions at different points. I guess you could say it's a lot of these heights right over here. But one thing that might jump out at you is you could construct rectangles, all that have width 1. And so if you multiplied the height times the width, the area is going to be the same thing as the height. So if we put a 1 times 1 right over here, this makes it very clear that you're taking the height times the width of this rectangle and then this rectangle. So you essentially have a bunch of left-handed rectangles that you could imagine are trying to estimate this bluish area that was shaded in. And it's clearly going to be an underestimate because it's giving up these areas. It's giving up those areas right over there. All of these rectangles are sitting, they're either just touching or they are below the actual function. So let me just write this right over here. This is going to be an underestimate of the area of this blue area. Now let's think about what this one is here. So this is f. So it's the same thing that we're taking the sum of. We're starting at I equals 1 and we're going at 10. So once again, 10 things. So negative 5 plus 1 is negative 4. F of that is this line right over here, is that line right over there. And so it looks like we're taking right-handed rectangles because we could say times 1. So times 1 would be the area. Obviously if we multiply by 1, we're not changing the value of this expression. So that would be the area of this first right-handed rectangle. Then when I is equal to 2, it's going to be f of negative 3. And so you're looking at this one right over here. And so let me draw at least this part of it. So it's going to look something like this. It's going to look something like this, where now we're dealing with right-handed rectangles. And these are clearly an overestimate. These are right-handed rectangles. So you're going to go all the way when I is equal to 10. Negative 5 plus 10 is 5 f of 5. That's this line right over here. Or this length right over here, f of 5. And of course, we're multiplying it by 1. So it's going to look like that. And we could keep going. I think you get the general idea now. These are all going to be right-handed. Well, these are all right-handed rectangles that I've drawn. And these are going to be an overestimate of the area because they all have this little extra, region right over here. So these are going to be an overestimate. Now let's think about this one right over here. We're going to start at I equals 1, and we're going to go to 20. And it looks like we're going to do rectangles. Instead of width 1, we're going to do width 1/2. And once again, since we're starting at I equals 1, these look like right-handed rectangles again. This is that we're going to use to estimate. So let me do this in a color that you can actually see. I'll do this in orange. I'll do this in orange right over here. So the first one's going to be negative 5 plus 1/2. So it's going to be this f of that, which is going to take you right over there. And then you're going to multiply it times the width, which is 1/2. So now we have twice as many right-handed rectangles. So it's going to look like this. Twice as, and I won't do all of them because it takes some time. We're going to have twice as many right-handed rectangles. So it's still going to be an overestimate, but it's going to be less of an overestimate than this one over here. Because this one over here, you had all of this extra green space above the function. Now we have a lot less extra space, above the function. So it's a better estimate, but it's still going to be an overestimate, because at least for this function right over here, because at least over this interval where the function is increasing, the right-handed rectangle is giving us overestimate. But this is a little bit more precise because we're using narrower rectangles to estimate. Overestimate, but less so. Than this one right over here. And this right over here, this is the definite integral from negative 5 to 5 of f of x dx. And you can imagine this is essentially the limit as we take these widths to be smaller and smaller and smaller, and we essentially end up having essentially an infinite number, or we approach an infinite number of these right over here. And this is the actual area. So this is what's actually depicted in blue. This is the actual area. So if I were to list this from largest to smallest, the biggest overestimate, this is the biggest overestimate right over there. Now this is still going to be an overestimate, but it's a little bit more precise because we have more rectangles. So I'll put that 2. Now this is the actual area, so I'll put that 3. And then this is actually an underestimate, so I would rank this 4. This is the largest of the values, and this is going to be the smallest of the values.